Okay, I hit record. Even though I just watched this, I was like, I gotta watch that again. These are.
In the middle of the Bighorn Basin near Worland, Wyoming. And I want to do this video kind of where I invite you guys to come along with me and unravel a mystery. One of the things that I enjoy about being a geologist is I have people in the communities that I interact with that say, hey, I've seen this really cool thing out in the hills or up in the mountains, and I think it's this or that, or I've heard it's this or that, and they want to know, curious people. And I've decided I want to do some videos where we just unravel geologic mysteries and think like a geologist and kind of walk through how a geologist approaches things that they see out in the field. And that's one of my favorite things to do, is just walk up to random outcrops of rock and figure out what's going on. So here I am at this giant tree, massive tree. It's just cut right here in front. And
when he said that, I was like, wait a minute, it's kind of sideways. Why would he call it a tree? And then these things are kind of weird. They're kind of Shiva shaligram weird. They're kind of common in a lot of places. I am excited to see these. And he will find out does not believe them to be trees, even though he just said these trees.
The local people think this is a great big tree, and for good reason. Look at it. It's beautiful, isn't it? You can see the edge here, great big. Well, let's get started looking at some details at this particular tree here. First of all, it's sitting on this beautiful sandstone right here. Beautiful buff-colored sandstone. And I've taken a photo with my macro lens to show you kind of what the sandstone looks like. It's a beautiful quartz sandstone, primarily with some lithic fragments or rock fragments within it. So we walk around and we look at this contact, and it is quite a sharp contact, just as you'd expect a big old tree to be down here, a big old tree. And from above, it certainly looks kind of like a tree. And
I was just looking down in here. That's real interesting the way. These are incredible. And then they just slice away. Slice.
and from above.
I wonder if this one will like break in half, kind of like that. It's from the lack of sandstone underneath it, eroding away across time because they're only thousands of years old. Maybe sometime some of them will erode away a bit more and fall away. Or they all just happened when they were formed and it's pretty much as it was. Maybe like one or two have fallen off. I don't know.
It certainly
Just speaking.
looks kind of like a tree. If I just take my hand here and set it...
And this block, the way there's blocks, like they are very reminiscent of the way Earth seems to have like chunks falling off. So like, that didn't make any sense what I just said. There it was, ammonites. Kind of like this one, where it's got a support structure underneath it, but then the water here passes through, erodes the mud in this instance, pretty much. And then it no longer can support the structure above, and that then is able to, under the weight of it no longer having support, fracture in this instance, or like break in some way, where effectively it falls off and is no longer part of the structure. It's possible. That's kind of what's going on with these and these and these, and just over time little chunks fall off until suddenly the part above is just simply no longer supported enough, and it falls off. And then the next part starts to erode away, and then the top falls off, and then erode away, top fall off.
On this sandstone and feel the texture of it. It's quite nice, and
maybe this is a good lesson for society. Erode away the supporting structure for society that society rests on. Yeah, so fuck everyone, just erode away. We hold them up on this nucleus of the United States or something.
I can feel that natural roughness. And I come up here and touch the sand. Up here, it feels very similar. So right away, I'm starting to think, well, this feels like sandstone to me, and it looks like sandstone. Indeed, looking at this macro photo confirms that it is sandstone and looks very similar to the underlying sandstone. That's a little unusual to have a tree that is replaced with sandstone. You can have a cast where there was a hole and filled in with sand of the tree shape, the original tree shape. But now I'm already starting to go, okay. But what else do you notice here? Look at what I'm seeing here. I'm seeing fractures right here. I hopefully have my camera on it. A fracture here.
This thing's so big it could be measured precisely, so precisely.
With cement in it, fracture here, and
in terms of like the distance between the fractures, all sorts of things could be measured about these things.
I say cement, where there's sandstone here, it feels like sandstone and it's cemented and it's more resistant to erosion. And look, if I turn the camera right down, you'll see these ribs poking out. And for me, as a geologist, I start thinking, well, there's cement that came in along these fractures and cemented up the sandstone a little better, with a little better cement or a little more to hold those sand grains together and make it more resistant to erosion. So that's an observation I'm making. I'm going, very interesting. Let me go up on top here and look at them from the top. So I'll come up here and walk along the top of this tree. So I get on top of this tree or sandstone body, or I'll just call it a body for now.
That's crazy the way it crossed over there. Doesn't seem to do it anywhere else I noticed. Let me even go back. That suggests a rotation involved too. If there's this one.
A tree or sandstone body, or I'll just call it a body for now. And you see these fractures with these ribs like we saw on the side, don't we? And I walk along right to the point, right out to the point. I'm so glad that I found out about this particular outcrop. Also, I see that this body, this tree that goes into the sandstone here, just like you'd expect with a tree. So, boy, okay, that's interesting. With the sandstone on sides, on the side of it over here, okay?
Oh, it's just crazy the way it just got smooth, smoothed.
Underneath here, and actually it looks to me like it's on top. See the sandstone on top? And it goes back into the hill over there. So I think there was sandstone on top of this. So now I'm starting to think, it seems to be encased in sandstone. That's what I'm starting to think. Which, of course, could be a tree, right? Okay, looking at the side of this again, if we look down, below we see nice sandstone, okay, clearly, easily sandstone, and it's pretty what we call massive, meaning I don't see bedding in it. I don't see bedding in this sandstone, okay? I see hints of bedding up here. I see hints of bedding in the sandstone here.
Oh dear God, this is probably what Earth is like right now. Just fucking all of it just supported on underlying pillars that are just eroding away.
See these little lines in here? I think that's bedding, those are bedding planes, okay? But when I'm first looking at an outcrop, I may not be real sure, so I look around some more to get more confident in my interpretation. I'm just kind of walking along and letting you think with me, okay? So let's make some observations on these other bodies. I'll refer...
This one's crazy because it just, like, what's the word I'm looking for? Not molds, but it morphs into the more traditional looking region over here. It doesn't really have nearly the distinctness, although it looks like it's just been more eroded also to just look, but also probably more eroded because it just wasn't as distinct, wasn't formed as like quite as well.
Refer to them using numbers 1, 2, and 3.
Or whatever, quite as much.
So I come here, here's the second one.
It's really incredible over there, all of it.
Well formed, very similar to the main one. And now I see, actually I see bedding that's pretty obvious to me.
This does not suggest rotation, really. I'm not sure why they were like crossing. Maybe it just does that when when the energy needs to turn.
Okay, in here. On the other side, it wasn't so clear. Here, definite bedding, okay, that I see in this body. Now let's examine body number 3.
Needs to turn because of some resistance it's facing in its travel, in essence. Like, looks like it turned here a bit, but I don't see any.
The first thing you notice is that this body or shape is not very well developed. It doesn't have the nice tree trunk or tubular shape the other two have, and the color is more subdued. And here you can very clearly see bedding that we call cross stratification, which is very common in many depositional environments, including river systems. Now I think I can safely say that all of the bodies are composed of cross-stratified sandstone. I'll tell you, as I walked up to this outcrop, the thing that caught me immediately, and it all jumped exactly what was going on as I came down and I started putting the picture together, is when I made this observation right here, right there. See that rounded back here? That's where this particular sand body, this body that looks like a tree, ends right here, right up against this nice sandstone right here. Okay, this nice sandstone. And also I see a rounded front to it, and it made me think of concretions, because it's got that nice rounded front, and I see those all the time, these giant concretions, and that's basically where cement grows within the rock, kind of almost like a crystal, and propagates out and cements up rock and the surrounding host rock, I should say, and makes it nice and cemented hard if you have the right cement. And then it weathers out as great big balls sometimes, giant balls. Okay, another interesting observation here on number 3, sand body number 3. The poorly preserved one will say, or it isn't as well formed is what I should say, is look here. We almost have a rind here. See this right here? And the shape under here? This is similar to what we see on the others, but the others are well formed and round over the top. These observations suggest to me that localized cementation created the rind we observe, and that the rounded base is the base of a small channel. In fact, the rounded bottom part of the other bodies are also very likely to be the base of small channels. I always like to ask myself, what is the age and the formation I'm observing? Well, it turns out we're in the Eocene, 50 million year old Willwood Formation. And that tells me some things. So this occurred, whatever was happening here, about 50 million years ago. It was in a river-dominated system, a lot of mud in the river system. I do know that from being a geologist, knowing this layer of rock. So that helps me, doesn't it? It gives me an advantage to know what formation I'm in. It's always important to check out the nearby area to look for clues and make observations. Here I observe a sandstone.
I'm like, da-da-da. Similar to that scene in Africa, Bahama fracture zone. Whoa. It's crazy that it's skeletal material that is probably not actually skeletal material. Calcium carbonate. Carbonates, this just seems so standard for these things that are like supernova emissions from the Earth in this period. I want to be surprised. Chalky appearance and presence of marine fossils. If it fizzes, the rock contains carbonate minerals. Dissolve and produce CO2 under acidic conditions. Oh my god, so the fucking landscape I live in could dissolve from acid rain. The government's surely gonna produce. Natural acids dissolve limestone over millions of years. Complex underground drainage systems. I probably do live over top some entrance to the earth. 34 to 55 million year old limestone formation, phase 3. Silicoclastic invasion. Yeah, moving northwest. I'm kind of tired. No one's paying attention to me, so why do I care? I'm like, I should read this aloud, but whatever. Oh my god, what a fucking massive deposition. Silicoclastic sediment. Good thing they're not fossils, dude. Oh, did you need? I need a license to collect fossils. It's not even a fossil, dude. Maybe learn what you're fucking telling me I can't collect. Boom. Clay silting quartz sand was deposited southward as deltas began overlaying carbonate platform. So land our area during the last interglacial. Oh, this was underwater. This was a pretty good article. If I was paying closer attention, I bet it'd be really...
body with similar coloring and cementation to the main outcrop. However, this body has more the shape of a small channel in a river system. Also, it is encased in mudstones, not sandstone. This particular sandstone body sure has a nice tree-like shape.
Was it literally resting on here? It's hard to say.
Notice that it has been broken up along pre-existing fractures.
Like, that looks like it could have some sort of spiral to it also.
The end of this sandstone
Hard to say, I need to see it a little bit more.
body has weathered out into a very
Pardon me.
nice rounded shape and reminds me of Concretion formation.
It's darker, it reminds me of a particle now that you mention it. Maybe that's a very good example of one of these particles encased in a shell of sand, just more brittle stone that's eroded away and exposed the particle. It's literally a particle.
Note that the body has sandstone on the sides and the top, just like the main outcrop. In this area, there are several small channel-shaped sandstone bodies with similar composition and coloring to the main outcrop. Note that these last two sandstone bodies are encased in shale, unlike the main outcrop. Boy, it's been fun making these.
I'm not sure what he's referring to there, this. Oh, I guess so. Yeah, this is on this white stuff.
Main outcrop.
They're way bigger and way more like a sheet. Like just a layer being formed there.
Boy, it's been fun making these observations together and looking at this outcrop and seeing what we think and walking around and investigating the area around. But now comes the fun part, and that is formulating a hypothesis as to what's going on around here and what happened 50 million years ago. I love this kind of work. I love it, getting out in the field and doing this. So the first point I want to make in this process, and the first statement that I'll make, is that this is absolutely not a petrified big tree trunk or something like that. It's not a petrified fossil of any kind. Furthermore, it is not a cast of a big, huge tree trunk or something to that effect, okay? So why would I say that with such confidence? Well, I've drawn a little sketch here to help us understand this together. So here I show a cross-sectional view, okay? So here's a person to kind of show you, make sure we understand it's cross-sectional. This big red outline represents a potential huge log or something like that. And these blue lines here are the sediments that covered that up, okay? Covered a log up. And this is how, in theory, potentially you could make a cast, okay? So what we observed that was so critical is that these tubes, these log-shaped bodies, were composed of sandstone. So to have a cast that's filled with sandstone, this would have to happen. You'd have a log in here that rotted away and left a big hole, and then sand came in and filled that hole. And this is really difficult to do because, first of all, it had to be covered to create this shape, this void, right? covered and then rotted away. So how do you get sand in there? But let's just say there's some little hole or something in there, and that later sand got into that hole left from the rotting log. Well, that's really tough to do, isn't it? Especially with this key observation that there's cross stratification within here. So we noticed in Outcrop that there's these cross stratification represented by these squiggly lines. And cross stratification only occurs when you have relatively high water velocities that deposit these move these sand grains along and make bed forms and cross stratification. So now it's, hey, come on. We can't put high velocity water inside a void. It's like a bubble buried in the ground like that. It just doesn't happen. There are some really cool casts, though, of petrified limbs and trees that I've seen, and I'll show you one here in a minute. So it can happen with a slightly different process. So, wow, okay, so we've made that step. We go, okay, it's not the petrified tree. It can't be. So now, what can it be, and what happened, and what is it? Let me show you another sketch. So now the sketch here to help us understand what I think is the best hypothesis as to what is going on or what happened 50 million years ago. But I have two sketches here, okay? One is a river system from a bird eye view, okay? This is the river channel here, okay? And that's a view from above. And next to it is a cross-section view of this river system. If we cut a channel across, or a big cut across here, we would see this view. And let me talk to each one separately. Okay, from the bird's view, sometimes you get river systems, a fairly wide river in this case, where the water will flow right here for a period like this, right? It'll flow down along the river. And then it'll switch it to over here and do something like this. And then over here, like this, through time. We call that kind of like a braided system. And so it builds a sand body that's bigger than any individual channel. So when the river's flowing here, the water's flowing through this area, it makes an individual channel. And it builds a broader body of sand, shown here. So if we cut across here and look at it sideways, cross-sectional, we have sand filling in a broader system. Now I've put some little smileys here. These are little individual channels. And I've also put at the base here some sandstone here, some sand that's massive, not bedded, like we observed in the outcrop, right? Now, after deposition, fluids entered this sandstone body here, this overall body of sandstone in the river that has a lot of individual channels, and the fluid localized along one of these little channels in here. So let's say it's this little guy here. The fluid started cementing up better a little channel, and the way it kind of like a concretion formation, it just keeps going and kind of fills in a tube shape, okay, like that, as it cements the sandstone that's above it. So the base of it is kind of controlled by the base of a little channel at one time or something to that effect. And the top of it grew in a more like a concretion. And that's why we see rounded ends to some of these things. And that's how we get a rounded top, because channels don't have a rounded top. They don't fill in with sandstone with a rounded top. So what happened? Fluid with more minerals, better cementation came in and kind of concreted, shall we say, making up words here, concreted into more of a round form like that, a tube shape. And to help us think about this hypothesis, what did we observe? Is we saw small channels that were actually channel shaped, but they were always encased in, or almost always encased in muds. They weren't surrounded by sand. They were encased in mudstones, okay? The nice little channels that we saw. All the round ones that I saw, the big, nice round log-shaped or tube-shaped features, were within a larger body of sandstone. They were encased in sandstone. So I
feel like sandstone versus mud is pretty much like the particle size. So it's more larger particles in the sandstone. Which kind of makes sense that the flows that are involved in making larger particles into these kinds of things are maybe going to be larger energies. And so they're going to be able to make more defined features maybe at times. And if it's only doing it with sand, with mud, then maybe it's just not enough energy. And it just happened to do it with, to the point of it just being mud still.
I wanted to discuss these mysterious...
Maybe it even causes the mud particles to conglomerate into larger particles from the flow that I think he's about to describe it.
Concretions, just a little more, okay, so we understand them a little better. I've sketched some sandstone layers here. They could be 5 or 10 feet thick or more, whatever it is. And these sands, when they're deposited, they get buried and water starts flowing through, mineral-rich waters start flowing through these sandstones, through these permeable sandstones. And that's when concretions typically start to grow. So what can happen? Well, let me start with the fun one first, and that is, I'll have a little fossil right here, right there in the sandstone, and it provides a seed point often, or can provide a seed point for cement to start to grow around that fossil into a sphere. So it'll just sit here growing cement, and sometimes these can get quite large, okay? But that's not always the way it occurs. Sometimes these concretions, it's hard to understand exactly what how they start. You know, it's kind of chaotic. We just know that the minerals in the water start to precipitate into cement. They're often iron rich, so you'll have like iron carbonates or iron oxides, but there are concretions that aren't necessarily that iron rich. We've seen some of that iron color on the concretions that we were looking at, you know, these giant tubular concretions, but it...
He said iron rich is a tendency, at least, maybe not necessarily, but a tendency then.
Rich, so you'll have like iron in the water start to precipitate into cement. They're often iron rich, so you'll have like iron carbonates or iron oxides, but there are concretions that aren't necessarily that iron rich.
These are likely tied to a supernova. So there's that side of iron, and also just the side of iron where maybe it's useful for conducting current.
We've seen some of that iron color on the concretions that we were looking at, you know, these giant tubular concretions, but it didn't seem to be overly iron rich when I would break open samples. So there's the fossil case. The other case is the waters are just moving along, and randomly or chaotically, it's probably not totally random, but chaos is certainly involved, they start growing concretions, and they can be very tube-shaped and get quite long and very interesting three-dimensional shapes. And that cement just
starts... Oh my God.
And very interesting three-dimensional shapes. And that cement just starts growing around these and creating these three-dimensional bodies. And they're often more durable than the surrounding sandstone that's also cemented, by the way, just not as good as this.
More dense.
And so with them being more durable, erosion leaves them behind.
More dense, maybe, is a good synonym.
Kind to stand alone, and so we might find a concretion just laying out on the ground. So I promised you I'd show you the cast of a fossilized tree. Okay, so this
Less porous.
technically isn't petrified. Some people would call this petrified, but this,
I imagine that the Earth's supernovas, fucking petrifying. Have, after being in this Hurricane Ian and walking outside and looking at the plants, those plants were fucking like, what just happened? They were not happy. They were petrified. I could see it in the plants after the hurricane, like the bushes, just just like their whole being, like they were literally like, how does a branch that grows like this, suddenly, like, not just the roots, like the roots are still in place, but the whole plant is like permanently, like, it has reshaped the plant because it's fucking petrified. It's like, what just happened? Like, that's not how storms usually are. They don't usually go for 24 hours or whatever. Fuck, blowing me always in one direction. This is petrifying. But just imagine, like, a supernova of the planet. I want to be surprised if, like, it's not a bad description either.
is a piece of tree. It's the cast of a tree. There were fractures in the rock, so it got fractured here
Like
and
fucking Medusa.
here, and it broke. And this is a piece of it, okay? Really cool shape. And the void, the hole that was filled in with mineral waters, quartz-rich, silica-rich waters, and filled in this void. And the void shape, the mold that was there, even preserved part of the bark texture. You can see the lines here and the nice texture of the bark. It almost looks like it is petrified wood. But then you look at the ends. Look what it filled in with. Chalcedony, microcrystalline quartz, really beautiful shapes. And you get looking in there, and
That's so cool. That's that thing right there.
there are little microcrystals, beautiful little microcrystals in there that are filling in.
There's so many crystals involved with fossils, which to me is just a telling sign that there is a crystallization process involved in literally in the whole of it, and just the whole of it, not just that there's a fossil, because they're not really necessarily fossils like that, like this. Like, this is not a fossil. If someone were to, like, suggest this was a fossil, like, it's easy to tell them it's not a fossil because, like, what the fuck kind of tree has all these, like, was a lumberjack cutting these trees up? Like, what the fuck are you talking about as a fossil? Like, it doesn't really make sense here. But, like, shaligrams and, like, ammonites, and, you know, the further into things that we call fossils we go, the more it's like, yeah, they're fossils, when no, they're not actually. They're just like this fucking tree that's not a fossil. Like, they're literally not fossils. Let's pull up a Shiva shaligram. That tree is like this, which is like, what was that cup? Which is like this, very similar to the point where it's probably the same process, just on different scales and different materials playing. And because of the scale of this, it's so small. Like if we couldn't see a zoomed in version of this, if this was literally like a millimeter, 2 millimeters, everyone who looked at it, what would they say? Fossil. They wouldn't be like, that's not a fossil. Well, that's, as we can see, there's lines that prove it's not a fossil. There's as like the bedding, like it's not a fossil. But when it's so small that it's like, well, it's a fossil. It's a fossil. Never mind that there were just ridiculous quantities of fossils where none of them were the same, really. Oh, look how many species of fossils. They were such stupid little cup piles, yet so brilliant. Look at all the cups they could possibly form. It's just like this one. This one's pretty much the same. I mean, it literally, like, if you could zoom that thing or shrink that to this size, like, at what point are we like, yeah, you know, maybe it's just the size that makes that it looks like a fossil, because like Dammit coon is not a fossil, but it's caused by the same process that we say to be fossils. So like, how's that? This is a shaligram. This is a shaligram. This is a shaligram. Yet there's, presumably, because these are, this probably is too. But this is like this. A shaligram. And so is this a shaligram. This here, I would like to see this guy's interpretation of this structure. So could you explain this? And more angles of this. Just everything about this would be amazing. But they're considered, like, this is considered to be caused by a fossil. Yet this structure is the same as this structure, like, generally speaking. Obviously, it's more nuanced than that. And then on top of that, like, the Himalayas, I'm finding, are caused by, well, are also composed, not the Himalayas, the Tibetan Plateau, north of the Tibetan Plateau, is the openings of a shaligram. I mean, it just is. It's just so large that it's not really been considered, but maybe people know. People know. Because they enter the earth from here, I'm fairly certain. And they know that they enter the earth from there, and they know that when they enter it, they see shaligram features, and they're like, oh. Like, they don't, it doesn't take much to enter the earth here physically see shaligram features within, and then leave and be like, okay, those shaligrams there are like what I just entered. But, yeah, that's kept for Tibetan monks probably. They don't share that secret with the world. Oh my god, this world. They leave that for my stupid, short-sighted, ignorant, white male American ass to come all in like a freaking typical European, causing a ruckus, trying to control things. Ugh. You had your turn, person who was just born in similar circumstances as everyone else. But your skin color had its turn. Skin color. Your genitalia has said enough. Put down that flag, young man. No, I don't even fucking support government, so that one's kind of like, come on. Like, I mean, obviously the other two, I can at least kind of understand since I am kind of a white male-ish kind of, but American, like, none of them are, no, none of them were chosen. I guess in some pre-game screen where you build your character, maybe I built the character and chose then, but I've in this life not chosen. But besides the point. Definitely related. I just don't know enough to draw the parallels. I'm starting to think things like this is not a fossil, like this is certainly not a fossil. This one is clearly more galactic like to a point where I'm like, alright guys, maybe be willing to entertain this when you hear it. I know how ridiculous it can come off, but like, dude, this is not a fossil. Anyone who looks at this for a little bit can tell that's not a fossil, so don't make me call this a fossil when you don't know. Obviously, the Earth can do this, so why the fuck would the Earth not be able to do this? It even has a rounded edge there. Rounded end. This to me is the same process. Not a fossil. Throw on top that we have, where is Myolingian? $509 to $497. They're big compared to. It seems like something happened around 500 million years ago, too, according to radiometric dating. That is in the Himalayas, for example. There's some oceanic crust in the Himalayas. I know we just say it's Tethys Sea closing up, but I call bullshit. I say that was emitted material that was just kind of hanging out, but emitted in that time frame. That seems to have been in a similar time frame to Ediacaran and Myolingian. Okay, so this wonder if I can look up other related. Evidence of asexual reproduction. You mean like not a fossil would have? Look at how they split off and like worms. They're like worms. Well, there's another one with the potential spiral thing going on. Oh my god. It looks like a little snake head. Tubular microfossils. I bet I could just go out and grab some sand and there's a pack full of shit that would be cool under the microscope and revealing about shapes of things, although I would not know what it was to look any further into it. And I would need a microscope, which I have had in the past. Before I found the theory of everything. Problematic tubular fossils. Remains of two adjacent coils. Wait, what? Why are they problematic? Unequivocally located within the tightly coiled parallel-sided helix of a diagenetically phosphatized specimen. Oh shit. So you're saying that they ain't fossils? Is that what you're saying? I think that's what they say. Clearly a cavity-dwelling organism within the post-mortal diagenetic cavity. Cavity-dwelling organism, like a intrusion. Insane. Okay, what are they actually talking about? Nice. This is how I would like to see shaligrams. Oh my god, nice. How much can I zoom in here before it gets too blurry? Oh, it's got like a core that it's wrapping around. Oh my god. I wonder if that's like a Birkeland current. It looks like it might rotate around it. Across enough distance. And this is just like a fragment of... Oh my god. Okay, this one. Inner tube at bottom of coil. Inner tube at top. Oh my god. Okay then. Access through your institute. Surely not short-sighted. Okay. Let's see what. I think that's a strong sign that they're not fossils, and I should keep going. They're not fossils. Alright, till next time.